What is light, a wave, a particle? What about an electron? Is it a tiny ball or something more mysterious? Welcome to the duality principle, one of the strangest and most fascinating ideas in modern physics. For a long time, scientists debated what light really was. In the 1600s, Isaac Newton believed light was made of tiny particles, or corpuscles. But Christian Huygens had another idea. He said light was a wave, like sound or water ripples. Huygens' wave theory explained many things: how light bends when it passes from air into water, how it reflects off mirrors, and later it helped explain interference and diffraction. In the 1800s, Thomas Young performed the famous double-slit experiment. He shone light through two narrow slits and watched it form a pattern of bright and dark bands on a screen. That pattern only made sense if light was interfering like waves. Where waves met in sync, they created bright spots. Where they canceled each other out, darkness. This was solid proof. Light behaved like a wave. Then came the 20th century, and with it a mystery. Scientists noticed that shining light on metal could knock electrons out of it, but only if the light was of a high enough frequency, not brightness. Even dim ultraviolet light could release electrons, but no matter how bright the red light was, nothing happened. Albert Einstein explained this using a bold idea. Light wasn't just a wave, it also came in discrete packets of energy, called photons. When a photon hit an electron with enough energy, it knocked it loose. This was the photoelectric effect, and it proved that light had particle-like behavior too. But the mystery deepens. Scientists decided to try the double-slit experiment again, but this time using electrons. Guess what? Even electrons, which are tiny matter particles, created an interference pattern, just like waves. This was shocking. Electrons aren't supposed to be waves, but somehow they were interfering with themselves. This led to one of the strangest discoveries in quantum physics: wave-particle duality. The idea that particles like photons and electrons behave like both waves and particles, depending on how you observe them. Sometimes they act like particles, other times they behave like waves, but never both at once. It depends entirely on the experiment, on how you choose to measure them. This duality opened the door to quantum mechanics, a field where certainty fades and probability rules. An electron isn't in one place, it's in many places at once until observed. Light isn't just a stream of waves or particles, it's something more, something quantum. So what is light? What is an electron? Are they particles? Waves? The answer is yes. That's the duality principle, a window into a universe far stranger than we ever imagined. Subscribe for more mind-blowing science.